from the XSLT working group, so please take it away.
Okay, well this originated from a W3C initiative to say it's a good idea to actually test interoperability of products and demonstrate it before you approve a spec. And it's not just, from my point of view, checking the interoperability of implementations of a spec, it's also checking the usability, because until you get to the final stage before releasing a spec, you don't get any implementations, and therefore you can't really try them out and you can't get feedback on usability. The main problem is, of course, if you discover that the spec's a disaster at the last stage, then you can't completely rewrite it. But what you can do is make minor tweaks to fix things that you find at the last minute. We did a sort of formal interoperability workshop in Prague, but we only got through a very small amount of what we hoped to achieve, because there was so much interest in the things we started off in. And the aim was to be interactive, and we were interactive, and we therefore dwelled on a few features. And so Charles invited us to come back here and not quite carry on where we left off, because it's a different audience, of course, but to workshop parts of the spec that we didn't get a chance to workshop in Prague. And we thought it would be a good idea to focus on one particular part of the spec, which is the packaging facilities. So that's the aim this morning. So the objectives are to introduce you to some of the XSLT3 features you may not be familiar with, and in particular the packaging features, but we may stray into other parts of the spec as we go along. To explore how those features work in two different implementations, Saxon and XSLT, and to get usability feedback. And for that purpose, we want it to be interactive. If you can, try out the examples, try variations on the examples on your own machines, connect to the GitHub repository, download the processors, try them out. Tell us what you're finding, ask questions, what happens if you do X, rather than doing what we've prepared. So the modus operandi, we want to be interactive. We've deliberately not over-prepared. I did an example this morning that I haven't shown Abel yet, so when he tries it on his processor live, it will be the first time. We want to break things. We want to find what's broken in the spec. We want to find what's broken in our products. If we don't find anything that's broken, then we will have failed. So the whole objective is to hit problems and identify them. One thing I haven't done in advance, I would really quite like it if someone captures everything that we find, and because we won't have time to make notes. Hirka, can you do that for us? Thanks very much. So let's look particularly about packaging. The objective in packaging is all about software engineering. It's about making XSLT code more robust, more reusable, making development of code more productive, giving you more flexibility as to how you deploy code, because you don't just use a style sheet in one place. You have to ship versions of style sheets around the place. And performance, not so much in terms of runtime performance, but we were beginning to recognize that the traditional interpretive style of using XSLT, where you compile the whole of DocBook in order to do one small transformation, is giving you a performance problem in terms of compile time performance, that there's scope for improvement there. So the first thing is to understand that style sheets, the name is a misnomer. DocBook is not a style sheet, it is a substantial piece of software. These figures are probably a bit out of date. I collected them a couple of years ago, and they might well have grown substantially since. But 5 particular examples I took of sets of style sheets, all with 100 to 400 modules in the style sheet, and the size in terms of lines of code makes them substantial pieces of software where what you really need to apply some engineering discipline to the reusability of bits of code there, to how that code is structured. The first four of those are all, well, DocBook and DITA and TEI are open source style sheet sets. Qt specs is the set of style sheets that we use for the production pipeline for publishing the W3 specifications themselves, which are probably the worst engineered set of style sheets you can possibly imagine. Because, of course, the cobbler's children problem applies. You know, who doesn't have any shoes? Answer the cobbler's children. And the last one is the online publishing system of an anonymous publisher, a scientific journal publisher, where I was doing some consultancy with the project. And at the time I was involved with the project, that's roughly the scale of it, but that's probably doubled since as well. So what's wrong with the system we've got in XSLT 1.0 and 2.0? Well, its plus points are it's well-defined, it's interoperable, and the customization that you get with XSLT style sheets is no doubt of very great value. That's a big plus feature in terms of reusability. The fact that you can take a base style sheet and create customizations of it is one of the very much plus points of XSLT. It is one of the major benefits of XSLT over XQuery that enables you to write large applications in XSLT. The downside is everything is public and global. If you've got 230 modules, every template, every function in those modules is visible to the whole world, which makes it very hard to know what you can change, who's using what the dependencies are between modules. Customization is all very well, but when you've got something that big, you actually want multiple customizations to coexist. I discovered that problem myself. I had a style sheet that was generating JSON. I had a customization of it to generate indented JSON. I wanted both of those customizations to coexist in the same application. You can't do that. So you find you want, writing one subclass of something isn't enough. You want to write multiple subclasses of it. No type safety, so you can't tell whether the customization is actually safe. And a consequence of not having the type safety is it just isn't designed for separate compilation. There's a technical reason why you can't compile XSLT modules independently of each other, which is that you don't know what's going to change in the customization. You can override a template with something that does something completely different, has a different signature, has different defaults, has different types. When you look at that template that you're calling, you have no idea what it's going to be overridden with. And that means your scope for making decisions at compile time until you've seen all the modules is very limited indeed. And as a result of that, with these large style sheet sets, compilation cost often dominates. We've been seeing that recently with some DITA workloads. People running DITA within Ant, they're compiling the whole of DITA and then doing a small transformation of a 2 KB document. And compiling DITA takes about 99% of the time compared with the actual transformation cost. And that's done every time you transform a small document. So people are transforming 300 documents, they're compiling the whole of DITA 300 times. And it's a ludicrous waste of machine cycles and electricity, quite honestly. So XSLT 3 packages what it aims to achieve. It aims to achieve the benefits of being well-defined and interoperable and customizable, but to add the ability to add multiple customizations. It gives you controlled visibility of components, so you say what's public, you say what's private, you say what you're exporting. The overriding is type safe, which gives you the ability to do separate compilation. Whether the implementation takes advantage of that is an implementation feature, but the language is designed to make it possible. And as a side effect of that, as the bottom line, Abel reminded me to put in, the fact that you can compile things and distribute things in compiled form gives you what's important to some users, which is IPR protection or a level of IPR protection. That again depends entirely on the implementation, but if you can compile things, then you can also distribute things in a form that makes it difficult or impossible to reverse compile, and that's important to some users. So, did you want to add anything there?
Yeah, on this last slide, I think you could add that, I mean, you can control the visibility of components, but the reverse is also true. If you use a package, you can control what you want to import, what you want to use, and ignore the rest. You can, I mean, that can help with situations where you simply don't need the whole package, or in situations that you would have otherwise name clashes.
Okay, so any questions about the requirements level that we're trying to address? Does it look like a useful thing to address? Have you hit these problems? See some nodding? Okay, so let's launch in and look at some examples. And rather than start with an example that's useful, we thought we might start with a sort of foo bar example that just shows the syntax without attempting to actually do anything useful with it.
Should we repeat where the GitHub repository is? For people that want to like, download it now and tag along. I can add the URI.
So do you want to?
Yeah, but I didn't have the URI there.
Well, no, but you can add it now.
All right.
So the technology we've got is that we can press a button to switch between screens, and you get a 5-second delay, so you can actually see that we're switching between screens, which is probably useful feedback. So you can download the examples that we've prepared from GitHub, and our only mechanism of exchanging them between ourselves is via GitHub, so we might occasionally stop to commit things and update so that we can try something on one processor and then see that the same thing works on another. I'll be running Saxon from the command line. That's because it's a later version than is integrated into Oxygen. And we're running bleeding edge stuff here. This is, an area where the core features have been implemented in Saxon 9.7, but they have not really been exposed to serious scalable testing. They run noddy examples, but they don't necessarily run real heavy workloads. And so running from the command line, and we may well find limitations. But let's concentrate on what's in the spec first.
Would you want to show how to use, the command line from Saxon as well, so people can?
I will, but let's look at the examples and then run them, and then move from there.
Yeah, all right.
Okay, so here's probably the simplest package you can imagine writing.
Back one.
Yeah. It's got an XSL package element at the top, which is new. Just to say this is a package, and it can have ordinary modules that begin with XSL style sheet or XSL transform within it. But just to emphasize that you're writing a package, we've introduced a new top-level element. The package has a name, and the name is a URI. And that URI is intended to be a name of the package rather than a location. Because the idea of a package is that it can exist in multiple locations. It's something you deploy. It's something DocBook exists in 10 million different places. But there's one URI that says this is the DocBook package. So it's a name rather than a location.
So it's not intended to dereference that?
It's not intended to be dereferenced, no. So it's like a namespace or...
So you could use any old scheme rather than HTTP?
Yeah. And there's a simple versioning system. So you can declare what the version is. That version number has a syntax. And there's a syntax for matching a range of versions or saying that I want a version later than this or a version within this range or whatever.
Yeah, but that's not here. I mean, that's when you use the package.
Yeah, sure.
I mean,
So the package declares what version it is, and then exactly how you pick up the version then depends on things which are outside the scope of the spec. But there might be some kind of catalogue that says what versions are, some kind of ability to search the system for different versions and decide which one you're going to pick up based on what the requirements are.
maybe a good moment to show how
Yep.
how a catalog can look like. So when you use Excel, when you use Excel, if you want to dereference those URIs of your packages, you have to tell Excel where these packages are. We have defined a package catalog, which is not part of the specification. It's processor dependent. And in this package catalog, you can say, for instance, search for anything with PXSL for XSL packages, or you can give exact locations based on the package name. So here you see the URI from the package that Michael just showed, and a bit to the right, you see the version, and the href is in this case a relative location, pack1.xsl. So this simply tells the processor, if I use a package with the name London 2016 package 1 with version 001, then you can find it in this directory in this location. That's actually all there is to it.
And we haven't got as far as doing that in Saxon yet. You have to register packages using the Java API, but we no doubt will have some similar kind of capability at some stage. Have you switched back to me?
Yep.
Yep. Okay, so what does the package contain? It just contains a function declaration. And the only thing that's different about that function declaration is that it's added a visibility attribute to say that this function is public. The default is that the function would be private if you don't actually declare it, which means you can only have calls within the same package. You can't have calls from another package. So here's an example of a very simple package that uses that one. Again, begins with an XSL package at the top level. This one's got a name as well. I think it's optional whether you give a name if you don't intend the thing to be used as a library package.
Yeah, it is optional, and it's also optional whether you start with the XSL package. I mean, if you want to use somebody else's package, you can also write in the traditional way with XSL style sheet or XSL transform on the top.
But I think Saxon's got restrictions at the moment that it has to be an XSL package and it has to have a name, even if it's the top level one. Because there have been spec changes along the line in that sort of thing as we've had usability feedback. What else can we see here? There's a use package element, and use package is like include or import, except it's the equivalent for packages. It says this is the name of the package I want to import, not import, use. I must not call it import. And this is the version I need. Now that version can be a range of versions. You can say star to say any version. You can say 0.0 star to say anything in that range. So there's a wildcard syntax for that. And then all this does is it invokes a function in that package. There's a few new XSLT 3.0 features here which we might mention in passing. One of them is that there's a default entry point to a style sheet called XSL initial template. So by default, the invocation of the style sheet will enter that template name. The other thing is the curly braces. We've adopted some XQuery-like syntax there. It's not actually the same semantics as XQuery, but the curly braces are short for an XSL value of expression. And for backwards compatibility, that's only activated if you say expand text equals yes. So I think you find when you start using 3.0, you find this feature very handy to get rid of all the XSL value of verbiage. But it has to be activated for compatibility reasons. Anything else that's worth saying about that one?
Yeah, I would like to show a slight variant of the same. Let's see. Switch. So here you see the same. Yeah, here you see the same used package with a small difference that I personally like to use. I always forget the package version that I typed in. Sometimes I use 1.0, sometimes 1.1 or 0.1. And in many cases, I just have one package anyway, so I don't really care about a version. Then you can use a star. The other thing I would like to emphasize is the XSL initial template. It is a reserved name. It's the only template name you can use that is in the XSL namespace, and it tells the processor if you don't know the entry point. I mean, you don't specify the initial template, but you do start your processor in template processing, named template processing mode. Then it will get the XSL initial template. It's similar to int main in C or the variants of main in Java or C#. And that's also why in, where was it? The command line, you can simply say XSLT-XSL pack 3 XSL. I'm not specifying that I want the initial template here because if I don't specify anything, the processor will figure out there is an XSL initial template and simply start right there. So, shall I attempt to run it?
Yeah, you're projecting, so you run it first and then I'll run it. And we'll see if we get the same answer.
All right. Oh, there's a bit of cheating here. Apparently so let's remove this here. I didn't run it before, so that's more like it. Control-Shift-T on Oxygen to run it on the predefined configuration. And there it is. Out 20, is that what we expect actually?
Yeah,
so,
I think so.
So what happened here is that this function was called with arguments 17 and 3. That function does not exist in this current style sheet or package. Instead, we imported it from here. It has 2 arguments, x and y, and it adds those arguments together. That's all there is to it. So
we'll just check that Saxon gives you the same thing. Let's see if I can expand this a bit. As I say, I'm using the command line here. Let's see where we're... I'm going to have to edit that because I've been doing some different examples. On the command line, you can give a list of packages and you give the locations. So it's pack 1 and pack 2.
well, pack 2 is the one you're going to execute. Pack 1 is the library package.
Yeah, okay. So this is pretty primitive user interface because I haven't got the configuration working at the moment. And they have to be in the right order. And I can...
Extension. Probably.
Oh, yes, indeed. Yeah, thank you. Okay, so same answer.
Hey, I think you did something different, but it is from your command line. It's a slight difference, but it was the XSL output indent yes.
Yeah.
Which I will add to my style sheet. Which maybe, I'm not sure if this is the right moment to say that, but the XSL output is one of these things that if you import, if you use a package, you use the definitions like functions, templates, modes, attribute sets. You don't use the output definitions. So the output definitions have to be defined in the principal package that you currently execute.
Yep. Or, of course, from the API or whatever. There's a slight difference in the Saxon command line as well, in that I've got this. Am I showing my screen?
Yeah, you're still showing your screen.
Okay. So I've got this -IT option. That's backwards compatibility on the Saxon command line. If you only have -XSL, then it assumes you want to apply templates invocation, finding a template rule that matches that. So it's already got a default for what happens if there's only a -XSL option, so I couldn't change that default. So you have to say -IT to say I want to start with an initial name template. You can just leave out the name XSL initial template, and it's now got a default name, so change the command line that way. So that is the very basics. Let's now look at overriding that template with something more interesting, or
Maybe,
overriding.
Maybe a brief moment or asking.
Sure. Any
Are you
questions?
any
about
questions
so far?
following the example so far? Anything clear, unclear? Shoot.
Is anyone running them?
Ah, not all together.
Okay, well, never mind. No one brave enough.
Not yet.
So let's look at as an override now. So what pack 3 does is it overrides that function. And I said it was a foo-bar example. So this replaces the addition by a multiplication. And what the override does is to say, within the scope of this using package, and that's a rather interesting term which accounts for an awful lot of complexity in the spec, but within the scope of this using package, when I say compute score, I mean this function rather than that function. So it replaces the function compute score within a certain domain by a revised version of that function. And when we now call compute score from this package, it's going to be that version that we get rather than the other version. So if we just check that we can run that.
Hold on, I would like to add something, because you did something here as well.
Right.
You changed, Michael changed the visibility to private, which in this particular case doesn't add much because we are in the principal package. If you say visibility private, means it's in the scope of the current package. But if somebody would use this new package, this principal package, as a library package in, let's say, a third style sheet to use it, it will not be able to access this same function anymore because now it is hidden. You cannot, when you use a package, you cannot use any private functions or other module components that you've been declared in the used package.
And in fact, we've recently changed the default there in response to usability feedback that came from discussions in Prague.
Yeah.
The default was public, or the default was to leave it unchanged, whereas the default is now to make it private. So there's a difference there between what the spec says and what Saxon implements, because we haven't implemented that change yet.
Me neither.
So let's run that. We'll change it to run package 3 instead of package 2. And we now get the output 51, which, if I can still do mental arithmetic, I think is right. So would you like to run it?
You want to have compatibility proof? Okay. It's not 20. By the way, here, I don't know if you can read that in the back, but this is the output from running it on the command line. and it gives you feedback of what kind of packages it has found based on your catalog. So let's run it. This was pack 3, x times y, looks like the right one. I got 51. Oh yeah, you had the indentation. Just being a programmer, I have to be precise. Oh yeah, actually, it's just a little thing, but in XSLT 3, you are not just restricted to true, false, but any Boolean attribute can now have false, no. What was it? 0 or 1?
It was yes and
false
no.
true.
It now allows false and true as well.
Yeah. What was I going to select? Yes. Well, there's the indentation.
Okay, right. So I suggest we look at some error conditions. Things you can get wrong by making the type signatures different or getting the visibility wrong or things like that.
Yeah, let's.
So try making the function you're trying to override private and see what happens there.
Yeah, so I'm changing it to private in the original package. I think I was using package 1. Yep, that was here. And if I run it now again, then it should not. Okay, that is in a small font, but I get XTSE 3060. Let's see if I can. So this is the error I get. The component fComputeScore referenced by an XSL override declaration has visibility other than public or abstract. So the component that I'm trying to override, fComputeScore, in the package that I'm using, is not public or abstract, so I'm not allowed to actually use it. It's inaccessible. That's what the error says.
And what Saxon says is the function named fComputeScore #2 in the used package cannot be overridden because its visibility is private. Yep. Let's try another error. Let's change that back to public. Oh no, let's change it to final this time. See what that says.
Should you explain what final does?
Final says you can't override it. Same as in many other languages. So it says it can't be overridden because its visibility is final. So final would allow you to call it, so the first style sheet would work, but this overriding one won't. So I'll change it back to public. But this time, what I'll do is that I'll claim it returns a decimal rather than an integer.
The return value?
And this time it says the overriding function, I'm getting some funny word wrap here because of fonts. The overriding function does not match the overridden function, the return type does not match. So even though it does return a decimal, and decimal is a subtype and so on, we require the signatures to be identical. You're not allowed to actually sort of refine the signature to assert that it's returning something more restrictive, because the type checking then on things that call it might need to be more precise, and the assumptions made by calling code about the signature might be invalidated. So we decided to be rigid about that and make it be exactly the same signature.
Okay, I made the same changes while you were talking. Changed the return type to XSL, XS decimal. Compatibility check. See what we get. All right, I get some red signs there. Copy it in here. I get the signature of an overriding component. fComputeScore is not compatible with the signature of the component that it is overriding. Well, repeat that a couple of times and you get quite dizzy, I think. But it's the same.
Yeah.
So far, so good.
So I'd like to move on to an example that does something a little bit more realistic, where you might actually want to have a library and do some overriding. And this is the one I haven't shown Abel yet, so it's going to be interesting. Switch over to me.
Yep.
So this is the problem, which is actually a problem that comes from my XSLT book, which says, how do you work out whether a graph has cycles? You sometimes have relationships, like the relationships of the reporting hierarchy in a company, and you want to assert that there aren't any cycles in the hierarchy. And the problem is you only want to write that code once to check for cycles, but the ways of representing relationships can be very different. And so you sort of want to parameterize the way that things are related and say, I want a general bit of algorithm for finding cycles that's parameterized by the way that things are connected. Now, one way of doing that in 3.0 is with higher order functions. But we're not doing higher order functions here, we're doing packages. So I wanted to do it using an abstract function to do the relationship, and that parameterizes the method of finding the closure. So this illustrates a few more features in the spec. This is the general purpose graph library, which is capable of finding the transitive closure of a relationship, and it's capable of telling you whether something participates in a cycle. So let's look at how I wrote this. This time I've used XSL expose to define a sort of formal interface as to what this package is exposing. These are the things that are public in this package. I've decided to put those up front. So it's almost documentary, but I could use it to actually restrict the visibility of things that have been declared within the package, which might be useful if you're reusing some general docbook library that doesn't declare visibility of things. I can encapsulate that in a package that does declare the visibility. So what I've said is it exposes two things as public. They're both functions. One is a function to compute the transitive closure of the things that are indirectly related to the place I start. And the other is to work out whether that closure includes a cycle, i.e. starting at A, can I reach A from where I started? And then I've got an abstract function which tells me what are the neighbors of a particular node in that graph. How do I get to the things that I'm connected to? So I've declared that function as abstract, which is just a function without a body. It just declares the signature, no body.
Actually, if you would provide a body in an abstract function, it's an error.
Yep. I've then got a function which is the public function to compute the transitive closure, and all that it does is to call a two-argument version of the same function, which is private. So it's passing the empty sequence as the second argument. The second argument is the route by which I got to the node, or the things that I've encountered on my way there. And the algorithm for computing the transitive closure says, first of all, bind the variable direct to the immediate neighbors, and then select the union of the immediate neighbors plus the transitive closure of anything that isn't on the route by which I got to where I am. So that avoids the transitive closure computation getting into a loop by if there is a cycle, it should terminate.
That's what you say.
That's what I say. Yep, it works on my test case. That's not to say it's bug-free. And then the second function, how do I test whether A indirectly refers to itself? The answer is, is it included in its own closure? So you compute the transitive closure. If that includes the place where you started, then you've got a loop. That might not be the most efficient algorithm for finding a cycle, but at least it's concise. Now, I can't run that on its own without a using package to supply an implementation of that abstract function. So here's a version that does supply that function. And in this, I'm going to use data like this, where I'm using ID ref relationships to define the linkage. So the neighbors are the things pointed to in the ID ref attribute. And so my implementation of the abstract function I'm going to use a key ID, which just to locate things with a particular ID. And my implementation of the function says, given a node as a starting point, I'm going to tokenize the ID ref attribute and then use the key function to locate all the things that are identified by one of those ID ref attributes, and that key is going to search from the root of the tree containing the place where I started. The key is local to a package, so key names are not shared. A key name is local to a package. Any sharing that's done might be an optimization.
Do I get this right? Can you scroll to the test data?
Yep.
So your idea is you check the ID refs of A,
Yep.
which are B, C, D. Then you check the ID refs of D, which is E and F.
Yep.
Which brings you to E and F, which has an ID ref of A, which goes back to the first.
Yeah. So
and you're trying to find that this is cyclic.
So there should be a cycle.
And you want to break the cycle.
Yeah. Yeah. So my test case then says, does A refer to itself, and does E refer to itself? And the answer I'm expecting is that A contains an indirect reference to itself, and E doesn't. And so if I run that, then it says A is cyclic true, E is cyclic false. Any questions about how that's supposed to work?
Everybody understand cyclic redundancy check?
So let's try it on XSLT.
Yeah, I actually know what's going to happen, but I'll let the surprise work for you. Let's just run
Remember, if it works on Saxon and doesn't work on XSLT, that might be a bug in Saxon.
Yeah, we may have to have some discussion on that. So in very small print, which is totally unreadable there, it says Excel transformation in progress. Well, since the input document is this size and we have only 3 lookups and it is still running,
that suggests there's a loop.
I think there's something not really what we expected. And in the same tiny font, it says Stack Overflow exception. So the cyclic dependency here from the private to public and whatever you are doing is not found.
Right. And now that might be that the code I've written relies on implementation-defined features of the way it's executed. It might rely on lazy evaluation, for example, that you don't evaluate a sequence fully before, that you evaluate things one at a time. So that might be a bit of a complex issue to explore here, but it's entirely possible, because order of evaluation is implementation dependent, that I've written an algorithm that terminates on one processor and doesn't terminate on another, and both are actually conformant with the spec in doing that.
So maybe, Jurke, you can add a note about that. We'll have a nice discussion on the next W3C meeting. I will have to investigate whether or not it is conformant that I have an eternal loop here that doesn't break. Well, the other way around, whether it is conformant to actually break the loop.
Yeah.
All right. Any questions so far?
I have a small one. I get an error if I try to run this in Excel. I get an error on the arity of the refers to self function. But that's likely because I'm using an older version of Excel.
No, I think I have the same version right here as you would have. You used the most recent. You have the package catalog in the same directory from.
I had to create one.
You had to create one. And
It's the March version or something.
yeah, it should be okay. I mean, nothing has changed in the respect of how packages have been dealt with. We'll have to compare. What's the other examples? Did that work, or is it the same error for everything?
The rest works.
The rest work. Okay. All right. Any other questions?
There was one thing we didn't mention, which was the XSL accept.
Oh yeah. I'll click this away. So let's put it on the screen. So an XSL accept declaration inside an XSL use package tells the processor which part of the used package, this case GraphLib, you actually want to use and how you want to expose it. In this case, you have to, well, I think we've made a change there in the spec, but you have to select what kind of component you're going to accept. That can be function, can be, I think, what was it, template?
Yeah, or variable, or
variable and modes. I think that these are the variants. Then with names, you give, how do you call that?
A space-separated list.
Yeah, a space-separated list of exact names, but you can also use wildcards here, like star reverse to self, or you can fully wildcard the whole thing and say every template that I want to use from the GraphLib has to become private. Actually, we had function there. It has the effect that if somebody's using the package I'm just looking at, cannot access the functions that I have used from yet another package. Often when you write your own libraries, you may be using, like, I don't know, a myriad of packages. And you don't want somebody that uses your library to see all the implementation details, all the functions and templates that you have been using from other third-party packages. It also provides, in the same manner, a way of what's the term? Information hiding? No, not information hiding. Intellectual property, that you can compile the whole bunch without exposing everything and saying, well, with this license for my package, you get all the functions. With this license for the package, you get a limited set of functions.
And it's also a way of dealing with name clashes. If a new version of the library comes along that adds a function with a particular name and that clashes with a name somewhere else, then you can say, I'm not interested in that new function that's been added. I don't want that name clash. Just you don't accept that function, and then it's not going to clash with one of your own. Yeah,
maybe if you can explain the difference between the accept and expose, because this function is not exposed actually in a package, which can be quite confusing.
Yeah. Let me try and do that with a bit of whiteboarding. I don't know if we have a way of projecting nothing, or do we have a felt pen?
There's one down there.
If I just do this, you have a white screen.
Right. So we've got a used package here.
No, it's all right. It's all right.
That defines, let's say, a function. And essentially what that offers to the outside world is filtered by an expose. So that acts as a sort of filter for what that function itself, what that package makes visible to the outside world. And then you've got another package here that uses this one, but what it accepts from it is filtered by an accept. So these components go through two filters before they get there. They go through the expose filter defined by the author of this package, and they then go through the accept filter defined by the author of that package. So both the supplier of the components and the consumer of the components can filter what's made available. So that's the distinction. Is that clearer?
Yeah, but then everything which is exposed doesn't have to be like declared by using expose. Because the way you have described, it can be like seen that this function refers to self. It's not exposed by XSL expose.
Yeah, if you don't have an expose, then everything then your default filter is that everything that's declared as public, your default is not to have a filter. In other words, to let everything through.
Yeah, but once
I thought the default was private.
Expose, then default is like not active because this function.
Okay, if I declare visibility equals public, then by default the filter will let that through. If I declare visibility equals private, then I can't expose it anyway. But what the expose allows me to do is to reduce the set of things that I'm making visible. So it can either be used in a purely documentary way to say here's a list of the things that I'm making available from this package, which can match all the things that you declared as public, or it can be used instead of declaring them individually public. If there's no visibility, so if visibility there is absent, then it's the expose that determines. So one style of writing things is to declare the visibility on each individual function. Another style of writing is to have no visibility attributes and put it all at the package level to say this is the interface I'm offering to the world. And that might be more suitable if you're wrapping an XSLT2 style sheet as a package to say this is what I want to expose. Yes?
So if the default is, if I don't define visibility, by default the function, for instance, would be private. Is that?
Yeah, the default will be private.
So if I then expose on that package, does that mean I'm not exposing anything?
No, if you use the default as by not supplying the visibility, then XSL exposed can override that default with public.
Yeah.
But
yes. So
the reverse is not true.
The default is private if there is no visibility attribute and no expose.
Right, with expose is a way of actually you can say I'm going to make. I don't have to write the visibility in my code. I can do that all by the expose function.
Yeah.
Yes. So the idea behind that, the introduction of this syntax is that if you have a 2.0 style sheet, you change the number to 3.0, you change the XSL style sheet into XSL package, you give the thing a name, then you add an XSL expose star visibility equals public, and everything you have, all the functions, all the templates you have, will be exposed. Then you can go through your style sheet which parts you actually want to have specifically as private. You're done. You just created the package out of the style sheet you already had.
So would you be able to control exposure using version of the package? This version later, say?
Yes. So I'm not sure if everybody heard it, but he's asking whether you can control the visibility of the same package with different versions. You can have multiple XSL use package. Each use package declaration can refer to, say, the same package, possibly with a different version. And inside that, you can say, what is the syntax again? XSL accept. So with XSL accept, you can then say on the version that you don't want, but you want only one function, you can deny everything and then write an XSL accept with that specific function of your 1.0 version. And then for your 2.0 package, you want all the other functions, and you can do the XSL accept star, for instance. So you could make, I don't think it's typically a good practice to mix certain versions of the same package in your style sheet, but maybe for compatibility.
But I mean, you know, you get this problem in the Java world. You get it in any big software engineering world. If you want to write an application that can handle both docbook and ditter, and docbook and ditter are two separate packages, and they both use the same URI handling package, but they use different versions of it.
Yeah.
Then the system is designed to cope with that. Docbook imports version 2 of the URI package, ditter imports version 3 of the URI package. You import both the docbook and the ditter, and they are using different versions of the same utility package underneath. That should work in theory.
Yeah, should we try to show with the code, I mean, maybe not with all the versions, but exposing and accepting and the visibility?
We can try.
With the simple example,
yeah,
because
yeah,
this
yeah.
one is breaking anyway. So
let's get rid of this.
So let's go back to our simplest example where we had a function compute score. Let's say, to see the difference, let's make it compute score public, and let's add one more function, compute score with no visibility. Let's call it default. Now, what we have just been saying, that if you have declarations with default visibility, you can override it with XSL expose. And what was the syntax?
It's attributes, component equals.
Oh yeah, component equals function, and visibility equals public. All right. You want to ride along, or you'll?
Or I can, if you do a commit, then I can update from it afterwards. I want to see where you're getting to first.
All right. So what I have here is one function with a specific visibility declaration, and one function without a visibility declaration. I am expecting.
You're still on decimal there, by the way.
Oh. Yeah, that is not going to work. Thank you. So I'm going to expect that in this case both of these functions will be available when I use this package. And I think we use them in here. So use package 1, version doesn't matter. So now I have a compute score public, and I have a compute score, okay, version 17 does not give me much help here. I mean version 17 of Oxygen. Let's say 25 and 35. The comma is just for creating a sequence, which will be output with a space in between, if I'm correct. I didn't yet specify something specific in XSL use package. So I'm using all the functions that were made public. And if I didn't make any typos, then this should work. Okay, my processor doesn't like it. The required names attribute is absent in the XSL expose instruction. Yes, there it is.
Names equals star.
Names equals star. So go back to the example, run it again. And I get 20 and 60. I believe that is what we expected. Now, one step further with the syntax that was on the whiteboard, we said that you could accept something and deny something. So let's deny something. I'm going to hide a function with the name fComputeScore public, and the one that was called fComputeScore default will remain. Now
Note that hidden is not the same as private. Private says it's visible within the using package, but it's not exposed by the using package. It's not exposed any further. Whereas hidden says it's not even visible within the using package.
This again can be handy in case of name clashes, that with the versioning example earlier, you could hide some functions that have the same name from another version of the package. So if I run this, I'm expecting an error. And the error I'm seeing, I will copy in the big screen. It is saying XTSE 3040, the visibility assigned to a component by an XL accept element. Okay, that needs some rewriting. Visibility type is incompatible with the visibility, blah, 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 of the corresponding component in the used package. So if you ignore the fact that something is not very human-friendly typed here.
What's it complaining about there? I don't understand that.
The visibility assigned to a component by an XL accept element is incompatible with the visibility of the component in the used package. I'm not saying it's the right error, but it's the error I get.
Okay, well commit it and let's see what I get.
So it's actually complaining that I'm making something hidden that was public, and it says that that is not allowed. Okay, I'll commit.
That feels to me as if it's something that should be allowed. So I'm interested to see whether I get the same answer.
All right. And now I need to push.
Did you commit first?
Yeah, I did. Oh my God, username. I honestly have no clue. Can I see somewhere what I signed up with? Do we have another way of sharing? Because I really don't think I know the username.
Right, okay.
Can I see that back here?
You might have
No.
You probably did an anonymous checkout.
Oh, okay.
So let's just replicate the changes here. Is I think probably the simplest.
Yeah, it was not big changes. So I copied the function.
So in pack1.xsl, we're first of all correcting that to an integer to revert that change. We're making a public version of that, and we're making a default version, is that right?
Yep.
And then, did we have an expose?
Yep. Expose with star. Yeah, component. No, component function.
Names equals star, and visibility, what should this be?
Public.
Public. And that's that one, yes?
Yep.
And then we'll be changing the pack 2 rather than the pack 3. Which was the other one?
Pack 2?
Yeah.
You have that open. And we added
XSL accept.
Yeah, with visibility hidden.
Component equals function. Visibility equals hidden. Names equals, what was the name we were accepting?
Name fComputeScore public. So the one that was explicitly public, we are trying to override and make hidden.
Do we need the arity on that? Did you have the arity on it?
No, I didn't. But you don't. I think without the arity, it takes any function that has this name. If you add #1 or #2, you say I want specifically that function with that arity, because in XSLT you can have overrides. Is it overrides?
Okay. Yeah. Let's see what I get with that. So we're using pack 2 and pack 1. I cannot find a matching 2-argument function named compute score. So that's objecting at I'm sorry?
It was compute score public and compute score default.
Oh, of course, yes. Thank you.
Oh, yeah.
Try that again. Right, so it's now saying it can't find a matching 2-argument function named compute score public, and that has a completely spurious line number.
Did you not have to accept statements directives in your original modified function? Because there is a single XSL accept. I think you had first one that imported or accepted, or then another one which did it.
You mean whether I use the same?
You have two XSL accept things.
This was my version. It was one. But you mean that the default of anything else that you accept will change to not accepted if you?
I thought you had two XSL accept statements that you only have one.
Yeah. No, I had one, but it does bring me on an interesting insight. If you use the XSL use package and you have the XSL accept, you might think that by writing XSL accept, you tell the processor what you want to accept and just forget about the rest. And I can't remember actually what the rules were there in the end.
No, I'm not sure. But first of all, this error message I'm getting, it's a little bit confusing, and the confusion is to do with the curly braces. Because what it's actually saying is, it says in out, and the out there is an element name. It's referring to that element name. And it's saying within the content of that element name there's an error, and it's identifying the position of that element name as so it's the out element on line 17, column 14, which is there. So it actually gives the end of the start tag. And it's then saying within that element, on line 1 of an expression within it, which is this expression, there's an error. So it's a little bit confusing there, which isn't helped by the choice of element name. But the actual error that it's trying to tell us about is that it can't find a function called compute score public, and the reason it can't find one is that we've made it hidden. So that's what Saxon is telling you. And if we change that from hidden to private, then it should find it. Yep, so now it works and produces an answer.
I would like to see what happened the positive scenario, so back to the hidden version, and then trying to call fComputeScore default.
Okay.
Meanwhile, I tried some variants on my machine and found that if I change the visibility to private, it behaves the way as when Saxon calls it with hidden. So my processor confuses private for hidden.
So it's succeeding in calling compute score default. There was no accept on that, so I think the default is it at least in Saxon's interpretation, the default is it accepts everything that's that was exposed. And sorry, this is it exposed everything as public. There was no visibility attribute, so it's the exposed that defines the visibility, and so it's visible, and so it can be called. Yeah, so complex interaction of the rules there.
Yeah, so in the end you can make it as hard or difficult or easy for yourself as you like. But if you get a lot of packages and with a lot of changes with expose and accept, I think it's quite easy to get lost at some point. I personally just prefer to, when I create a package, to have it define what I want public in that package and simply accept everything.
Is there a question there?
Yes.
Yeah. Another question, it would expose and accept would work the same way with visibility abstract, wouldn't it? You would be able to expose abstract functions and
You're very constrained in how you... If something's abstract, then you can only expose it as abstract, basically.
yes.
You're allowed to say so, but no, there's actually one exception to that. You can expose it as hidden, and if something's abstract and you expose it as hidden, then that's effectively saying anyone who calls that function gets an error. But it's not a static error. It's saying I'm not interested in that function. It plays no role in my application. I'm not going to provide an implementation because I don't need one. If anyone does end up calling it, then it becomes an error.
Yeah, there is one thing you might do, though I'm not sure of a use case for that, but you can actually accept a public component, override it, change the visibility to abstract, provide a new function without a body, and then defer the implementation to somebody using your package.
Need to check that. Let's.
Any debuggability mechanisms?
I'm sorry?
Are there any debuggability mechanisms? So print out a list of things that are visible?
Yeah,
well,
that's interesting.
that's very much implementation concern, isn't it? So it's a shame George isn't here, because I'm sure.
Perhaps some functions?
Sorry.
Perhaps some functions to give us a list of things, visibility, functions how to use, perhaps?
Yeah, I think it's useful.
There's certainly scope for addressing usability in that sort of area. One more question there.
I did the spring bean kind of dependency graph yesterday, so maybe it's something similar. If it's hard, you want a visual representation of your dependency graph in the scenarios that allow it here. So yes, at a code level, then also if you get the visual, what are the ones that you could be overriding and
yeah, there are enormous opportunities for people writing IDEs here to add value.
I think it's definitely useful if you'd have, but it's of course processor dependent, a command line switch saying dump everything that is publicly accessible from that package. I think it may not be as easy to also dump everything that's private, because if you have a compiled package, your interface may actually be hiding that or have, well, it's not accessible anymore.
We're running up towards time now, but there's one other thing I'd like to show, and that's XSL Original.
Oh yeah.
Interesting. So if we look at where we were overriding the function, we're overriding a function compute score that adds with one that multiplies. One thing we can do there is invoke the original function. So let's, instead of doing that, do XSL original $x, $y plus 1. So that invokes the function that we're overriding and then adds 1 to the answer. Let's just test that. We're now running pack 3 and pack 1. So I think the answer should be 21. Whoopsie daisy. That's not nice. Okay, right. Failure there. We've succeeded. We found a bug.
I think you changed the name of compute score in the original.
Okay. Yep.
So you may try to override.
That might be the reason. What was it? Compute score public we should be using.
So I guess you'd expect a different kind of error instead of the stack done.
Yep, very much so. Yeah, so this is now giving the correct answer, 21. So it was a bug on an error path.
All right, so I just did something slightly different, but still the same. Kind of. What were you typing? Oh yeah, so you were actually calling the original and do nothing. Well, actually passing on the same arguments. I'm calling the original here with some default arguments and add the multiplication. And if I run that, I get 61, which I'm not even sure is correct. What was the original? Was 5 plus 5, right?
Yeah.
So that's 10.
10 plus 51. Yeah, that's okay.
Okay.
Yeah, yeah. And so that mechanism, XSL original, applies it not only to functions, but also to name templates and to variables and all the other things you can override.
So is that like calling super method?
Yeah, yeah.
What did you say? Calling super?
Calling super. In,
oh, super.
In
oh, yeah.
Like Java or C#. Yeah.
Yeah. So how are we with time?
We've got about 10 minutes.
10 minutes. All right.
Okay.
Can you use multiple packages, more than one of which overrides the same named function, and can they each, is there a chain of inheritance? Can they call original up the chain? And
Yep, yep.
Well, yes and no.
You can do all that, and it can get quite complicated. I think one of the things that might be worth showing is what happens when you call a function that isn't overridden, that itself calls something that is. So that might be a useful thing to look at if we've got time. So if I've got a package with two functions A and B, and A calls B, and from outside I make a call on A, and I haven't overridden A, but I have overridden B, then it will invoke the override on B. So let's try that one, shall we?
Sorry, okay.
Who's projecting at the moment?
I'm apparently projecting.
You want
me
to try it?
Yeah.
Yeah. So let's call them A and B.
What? This A and B?
Yeah.
A
and
B.
Yeah. And let's just simply delegate. So A invokes B and adds 1. So it calls f of B with $x and $y, and then it adds 1. So plus 1 to the answer in here.
Oh yeah. All right. Sorry. Okay.
And they're both public. We've exposed them both as public. And in the calling style sheet, we'll override B.
The override one that was here.
Yep.
Overrides B.
And we'll make it, let's say, make it multiply. So it does $x star $y without an original, just to keep things simpler.
So what are we expecting here?
And then we invoke A here. And so we're expecting that to invoke the original A, which invokes...
So FA invokes this one.
Yep. And that should now invoke the overridden B.
And FB is not going to add, but is going to multiply.
So we should get 52.
And yeah, that should get 52, because then after multiplication it's done and it still adds 1 here. I agree. Now let's see if my processor agrees too. Oh, apparently not. Cannot load XML documents. I made a typo somewhere.
Yeah, there are quotes missing in the name attribute of the function.
Thank you. component FB referenced by an XSL override declaration has visibility other than public or abstract. Component FB referenced by an XSL override. Was this the one where I changed the visibility? Visibility is public. Yeah, so I think it doesn't like the default here. So let's say I change that. Yeah, that looks better. All right, I got 52 after a little bit of correcting my own
so
mistakes.
I'd just like to switch it to projecting mine, and we'll see whether we get the same thing. I'm overriding B node to multiply X and Y, yes?
Yep.
And I'm invoking FA here, is that correct?
Yep, I believe so. Yep.
Okay, so let's run that and see what happens. I get 21. That's not good news. And
can you show the original declarations in the used package? I mean in pack1.xsl?
Yep.
+1.
Yeah, but the call said 17.3, so that's 21.
Oh, because no, I think it's
17 plus 3 plus 1 is 21.
yes, but it shouldn't be adding, it should be multiplying because I've overridden FB.
FBXY.
Yeah. So that should be invoking the A in the other package, which invokes B, and it should get the override of B, and therefore does the multiplication.
Yeah, you do have the same as I have.
And that doesn't seem to be working. So either I've done something wrong or my product is doing something wrong.
You override B. And you call FA, yeah.
Yep, okay.
So
right.
far I
So
see.
something to look at.
Okay. All right, so I have to look at the visibility. You have to look at overrides.
Yeah.
All right, any questions?
Currently in the W3C test suite, we've got about 50 tests for all this functionality, and it's not nearly enough. We need about 500.
Anybody wants to volunteer for some test writing? The test suite is open. I mean, it has been made open about a year or 2 years ago.
Yes, it's open read-only.
Yeah.
In W3C Mercurial repository.
But if you do want to add tests, you can always add a bug report in the public W3C and say like, hey, I have some tests, please add them. You can also just mail Mike or me.
If you submit a bug report against my product and it's sufficiently reproducible, then I'll add it to the W3C test suite automatically. So, was that useful? Any more questions? Yep.
Could you go as far as overriding some of the built-in XPath functions?
Yeah, that's an interesting one.
Mm.
But
the
answer is no.
You can only override your own. You'd have to encapsulate them first and then override the encapsulation.
The reason that's not possible is that you cannot define a function in the namespace of the XPath functions. So you can also not override these because you cannot use it.
In addition, it's very useful for a processor to have built-in knowledge of those functions. So it knows that concat means concat and knows the semantics of concat.
It can optimize it.
Yeah.
Doesn't have to expect an override.
Yep.
So is it the same mechanism that applies if you call, let's say, apply imports instead of functions?
Yeah, apply imports is rather different. We haven't talked about mode overriding. One of the objects that you can override are named functions, named variables, named attribute sets, named templates, and named modes. If you override a mode, it's rather different because you don't replace the contents of a mode, you add additional rules to the mode. And if you add additional rules to the mode, then it works very much like import works in that the new rules sort of take precedence over the ones that you've imported. You can use next match, I think. I don't think you can use apply imports, but next match will do the right thing of invoking the template rule that you would have got if you hadn't overridden it. So there's a whole load of machinery for overriding modes as well. Yep.
And of course, the big difference between using XSL import and packages is that you don't have information hiding with imports. I mean, the apply imports with the XSL import statements has everything public with all the problems that come with it, and with packages, you don't.
So you get the visibility at the level of a mode there, rather than at the level of individual template rules.
And I believe you can't override the default mode or expose it.
The unnamed mode is private to every package.
Yeah.
So every package has its own unnamed mode. Okay, right. I think we're done.
Thank you, Michael. Thank you, Abel.
Well.